In this video, I'm picking up where we left off after simulating our horizontal roughing, and I'm going to move back over to my program now, and we'll look at some of the finishing passes that we can do. And I'm going to start with our first object here and try to calculate a parallel finishing. If we go up, so I'll start by selecting my curve region here with the part. I'm going to turn off the stock visibility for now. And so with my part region selected, I'll go up to machining operations, 3-axis, and so my parallel finishing is right here. Right away I'm going to move over to my tool tab, and so this surface that I'm going to be carving has some double curvature to it, so it's curving in across the X and Y axes at the same time. So I want to use my round tool to carve the surface of this. So I'm going to select, it doesn't matter too much which one, but I'm going to use again my 1/2-inch tool, but this time a ball end cutter, with the hopes that it's going to give me a better definition of these curved surfaces. This will be the second tool in my program, so I'm going to go to the change the tool to tool number 2. So I've clicked edit, create, select tool. That'll open up the tool window, and I'll change this tool number to 2, save edits to tool, OK, and now my tool number is updated. Under feeds and speeds, I'm going to just click load from tool. You can see the settings are the same as our flat cutter. Clearance plane, I don't need to adjust that value. Under cut parameters, so this is really the only thing we need to adjust for the parallel finishing. So the most important part of this is going to be our step over. So we can either determine the step over based on the tool diameter, or we can use a distance. We typically in the lab will use a distance, and we sort of have an idea of what level of surface finish we can expect from different tools using a set step over distance. The range that we usually use would be like 0.08 inches for a really coarse finishing. More commonly we're going to use like a 0.04 to 0.06 inch step over, and if we wanted a really fine finish, we might go to a 0.01 or 0.02 step over. And so I'm going to start with a 0.06 just to look at what that gives us as a result in our simulation, and I'll talk about it, and then maybe we'll look at we'll change this and look at what the results are and talk about what that means for our program. The other thing we can change here that can be really useful is the angle of the cuts. By default, it shows you what the angle will be right here. So if You can use this as a reference, but so the angle of 0 is left to right if you were in top view, and then an angle of 90 is going to orient the cuts to the y-axis, so they'll be going up and down if you were in top view in Rhino. For now, we'll just leave that at 0. There's not much to adjust on the rest of the tabs here. I'll just go through them quickly. There is Z containment allows you to sort of set a specific height area where maybe you don't want a machine below or above a certain area, a certain Z height in your file. The entry exit, we don't typically adjust or add like any soft entry since most of the roughing, most of the harder work was done in the roughing pass, and with the really small step over value that we're using, it's not going to generate a lot of stress on the tool, so we don't need to worry so much about that soft entry. Advanced cut parameters, again, this doesn't need to be adjusted typically. Sorting, also, there's some options here that we don't need to worry about for this purpose, or this example. So really all we need to do is set our step over here. We could adjust the angle if we wanted to, but then we'll click generate. And I want to turn my toolpath visibility on. So now you can see that it's generated a grid of parallel lines that are now running over the top of my surface. And if I simulate to the end of this, you can see the simulations for these will be a little bit pixelated. The graphics are a little off, and it's not totally representational of the surface quality that you would get, but it's a good estimation. And so now that it's done, what you can see here is that with the round bottom on this tool, you get some little bits of round edges in the surface. And so if we increase the step over, those round edges are going to be more pronounced. And if you decrease the step over, they'll be less noticeable. But what's important about that is understanding what level of surface finish you want and how long it's going to take. So if we increase, just double clicking on my pass here, finishing pass. If I go to cut parameters, if I increase this distance, I'll have a rougher surface quality. So I'll make this 0.125 or 1/8 of an inch. And now if I simulate that, you can see that those edges become much more pronounced. but that could save me quite a bit of time. This is now my step over is twice as much as it was. So my time estimation, if I right click and get my information here, so now I have just about 2 minutes to do that finishing pass, where if I double click my operation and change it back, I'll go to cut parameters, 0.06, reduce it down. I'm going to get a better surface finish, but now it's twice the amount of time. For a part this small, obviously it's probably going to be beneficial to just go ahead with the finer level of finish and wait the extra minute and a half. But if you're applying this to a really large site model or something of that sort, the time can really add up, and if you can adjust your finishing pass, you can save a lot of time that way. I'm going to stop with that for now, and in the next video we'll start to look at some of the other geometry that we have here and some of the other finishing operations. Thanks.